The agent loop turns Claude from a responder into a task operator. It lets Claude plan a path before taking action. Claude uses approved tools to carry out tasks. It observes real results from those actions. Then it revises the next step based on feedback. This approach handles uncertainty well. It works with external systems and partial data. Even when failures occur, it avoids guesswork. A single prompt works for clear, contained tasks. It fails when state checking is needed. It struggles with tool calls or result comparisons. It can't adapt after a failure occurs. Production work isn't one clean request, it's a chain of decisions. Each step changes what comes next. Most failed automation stems from systems that act without observing. They generate a plan and call an API, assuming success. Real environments often disagree with these assumptions. APIs time out, records are missing, and customers have duplicate profiles. Search results can also conflict and contradict each other. Without observation, Claude cannot know if its action worked. Without revision, the system repeats stale assumptions. It gains confidence without any real evidence to support it. The loop solves this by making each action produce feedback. Claude plans the next move based on that feedback. He then requests a tool to carry out the plan. The system receives an observation from the tool's result. It updates the plan using the new information. This makes the architecture adaptive, not linear. The system no longer needs every step predefined upfront. It only requires clear goals and safe tools. Reliable observations are essential for progress. Stopping conditions prevent endless loops. Planning is not a long essay. It is a compact operating map. Claude should identify the goal. He needs to know the required information. He must assess available tools. He should evaluate the risk level. He must determine the next best action. A good plan narrows the search space. It does this before execution begins. A bad plan turns the agent into a wanderer. It burns tokens needlessly. It calls tools without clear purpose. It hides uncertainty behind fluent language. Action is where architecture meets security. Claude should not access databases directly. It should not interact with payment systems. It should not reach admin panels on its own. Instead, it requests a tool call with typed parameters. The backend checks permissions before proceeding. It validates input shape and tenant access. It ensures business policies are followed. The model suggests a move. The application decides if the move is allowed. Observation gives Claude contact with reality. Tool outputs, error codes, and search results matter. Database records and test failures provide real context. User confirmations add reliable input for decisions. Observations must be structured and concise. They need to be trustworthy and clear. Vague or raw data creates confusion. Overloaded inputs drown out the signal. Without clarity, the loop drifts from the task. Revision shows the agent isn't just following a script. Claude checks the observation against the goal. It decides if the plan still makes sense. Then it picks the next step. It might retry, switch tools, or ask for help. It could reduce the scope or stop altogether. Strong revision turns failure into recovery. A production loop must be bounded. Define maximum steps and retry budgets. Set timeout rules and cost ceilings. Control tool permissions and memory scope. Include human approval gates. Autonomy without limits is operational risk. The safest agent isn't the one that can do everything. It's the one that knows when to continue, pause, escalate, or stop. Not every task needs an agent loop. If the path is predictable, use a workflow. Workflows have fixed steps and programmatic checks. If the path depends on evidence or tool results, use an agent. Uncertain context also calls for an agent. The architect must choose the minimum intelligence needed. Too much autonomy increases latency and cost. unnecessary autonomy also raises the failure surface. Agent evaluation must check behavior, not just final answers. It should track whether Claude planned correctly, did choose the right tool for the task, were valid parameters passed, was the observation interpreted accurately, did it revise safely when needed, did it stop at the right time. Logs and traces help reveal reliability. Golden tasks show consistent performance. Failure simulations test real-world robustness. Is the loop dependable or just impressive in demos? The mature pattern is governed iteration. Plan gives direction to the process. Act creates meaningful change. Observe gathers real-time evidence. Revise restores alignment with goals. When constrained by back-end policy, tool design, observability, and oversight, Claude becomes more than a chatbot. It transforms into a controlled agentic system. It can navigate real workflows safely without losing safety, context, or accountability.